So in this video, we're going to talk about exponents and how we can use the properties of exponents to simplify exponential expressions. So first of all, just real quick, what is an exponent? Well, if we look here, we see our first exponential expression. And now there's two parts to this. We have the base, which in this case is x, okay, and then we have the exponent, which is telling us how many times we're multiplying the base with itself, which is 5. So x to the 5th power does not mean x times 5. X to the 5th power means x times x times x times x times x. So multiplies the base with itself 5 times. So with that being said, what would 7 to the 8th power be? Well, it would be 7 times 7 times 7 times 7, so that's 4. Times 7 times 7 times 7 times 7. All right, and so, that's kind of why we like to use exponents, so we don't have to write all that out. Now, one thing I need to mention real quick, we call this exponential form. All right, that's exponential form, when you have your base and you have your exponent. And we call this right here, we call it expanded form. Okay, and that's just because it is expanded, it is written out. We've written out all 8 of the 7s that are being multiplied together. So again, this right here would be exponential form, base x with an exponent of 5, and then this right here is expanded form. Alright, so the first property we're going to talk about is the product of powers. Now product, meaning multiplication, and so if we look here, at the first example, we have the exponential expression x to the 5th times x to the 2nd power. Now, what we have to notice first is, do these have the same base? And in this case, yes, they have the same base. So for this to work, you have to be multiplying two or more values that have the same base. Now, when you do that, what you're going to do is you're going to keep the same base and you're going to add your exponents. So x to the 5th power times x to the 2nd power becomes x to the 7th power. Now let me show you why that is just real quick. So x to the 5th power is really x times x times x times x times x. So there's 5 of them. Then if we multiply it with x to the 2nd power, we're multiplying with 2 more x's. So now if we were to count up all those x's right here, that gives us 7 of them. Therefore, we have x to the 7th power. So that's why that property works. All right, so let's go ahead and move on to the next one now. And they're going to get increasingly more challenging, just with a few more components to them. So let's look at the next one. So we have 7y to the 2nd power times 2y to the 12th power. Now, we can just go ahead and multiply our coefficient values. So 7 times 2 is going to be 14. Then we see we have y to the 2nd power and y to the 12th power. Those share the same base. So again, what are we going to do with those exponents? Well, we're going to add them. So we get 14y to the 14th power. And that would be our answer right there. And now let's do the last one. So we have x to the 4th power, y to the 8th power, times x to the 3rd power, y to the negative 4th power. So it's important to note, we can't multiply this x with this y. We need to keep the same bases being multiplied together. So we can multiply x to the 4th with x to the 3rd, and that's going to give us x to the 7th power. Now we do y to the 8th times y to the negative 4th. Well, we threw in that negative there, so again, we have to add our exponents. So we do 8 plus negative 4. So what is 8 plus negative 4? Well, that's going to give us y to the 4th power. Alright, so the next property we're going to talk about is the quotient of powers. And so quotient in math is when we're dealing with division. And so this one is essentially the opposite of the last property we just did. So when you divide two exponential expressions that have the same base, so in this case we have z to the 5th divided by z to the 2nd power, okay, those share the same base and both have z. What you're going to do is you're going to subtract your exponents. So in this case, we get z to the 3rd power, or z cubed. So that's how we do that. Now, a very common way you're going to see it is written as a fraction, because in math, fractions just mean division, essentially. And so what we're going to do is we're going to divide our numerator by our denominator. Now, first thing we can do is we can just do 15 divided by 5. So that's going to be 3. Okay, and then y to the 8th power divided by y to the 2nd power. Well, again, we just take our exponents, that 8 and that 2, and subtract them. So we get y to the 6th power. And that would be our solution. All right, now on this one, I want to challenge you to go ahead and pause the video and try this one on your own. All right, and so now that you've tried it, let's go ahead and do this now. So both the numerator and the denominator have 3 different variables. However, we can only work with the same base. So we have x to the 8th, and we're going to divide it with x to the 2nd. So x to the 8th divided by x to the 2nd power, that gives us x to the 6th power, because we're just going to subtract our exponents. And then so same thing for y. We get y to the 4th power here, because 6 minus 2 is 4. Now we have z to the 3rd power divided by z to the negative 5th. So that's going to be 3 minus negative 5, which is going to equal what? Well, it's going to give us 8. So z to the 8th power. So the next one is what we call power of a power rule. And essentially what it means is if you have an exponential value, so x to the 3rd power, and that is inside parentheses, and that whole thing is being raised to the 5th power, what you're going to do is you're going to take your 2 exponents and you're going to multiply them. All right, so we get x to the 3rd power raised to the 5th power. That'll be 3 times 5, so we get x to the 15th power. And that's essentially how you do that. Now let's look at number 2. Let's take it a step further. If you see something like this where you have a few different values, so you have your coefficient of 2, you have x to the 3rd power, and then y to the 8th power. Now that whole thing, it's all in parentheses, so this entire thing right here is being raised to the 2nd power. It's being squared. And so we could almost think of this as the distribution property. We're going to say that our exponent of 2 is going to distribute with all 3 of these values. Now the 2 doesn't explicitly have an exponent given, so we're going to raise that 2 to the 2nd power. So 2 to the 2nd power. Okay, now again, when you have an exponent raised to another exponent, you're just going to multiply them. So we get x to the 6th power, then y, so 8 times 2, we get y to the 16th power. Now, you know, it kind of depends on the teacher you have and everything, but this would be a correct answer, but also 2 to the 2nd power, you know, that's just 2 times 2, and that equals 4. So you could kind of simplify this down to 4x to the 6th, y to the 16th power. All right, so for number 3, now we have a to the 4th power, b to the 5th power, over c to the 2nd power, and now that entire thing is being cubed. Now, one thing I think it's important for us to know is that a to the 4th power, b to the 5th power, these two values, since they're variables and they're paired together like that, they are being multiplied. So it's really a to the 4th power times times b to the 5th power, and then these values are being divided by c to the 2nd power. Okay, and then the whole thing is being raised to the 3rd power. So a lot going on here. But, you know, we can simplify this pretty easily. We're going to take our exponent of 3 and we are going to distribute it out to all of our terms. So a to the 4th raised to the 3rd power becomes a to the 12th power. Okay, then we have b to the 5th power raised to the 3rd power. So we get a to the 12th power times b to the 15th power in our numerator. And then in our denominator, we have c to the 2nd power raised to the 3rd power. That becomes c to the 6th power. And this rule right here is actually one of the properties. It's the power of a quotient. So if you'll notice within the parentheses, what we have is a fraction. We had a to the 4th, b to the 5th, over c to the 2nd power, and that whole thing is being raised to the power of 3. So we call that the power of a quotient rule right there. All right, so this next property is a pretty simple one. It's called the zero power rule, and essentially what it means is whenever you have a value raised to the 0th power, it equals 1. So essentially if you have something raised to the 0th power, it equals 1. Now, it might not always be written explicitly that easily, But, it'll be the same rule applying whenever you end up with an exponent of 0. So now on the second example, we have 2 to the 5th power times 2 to the negative 5th. So remember our first property. If you have the same base and you're multiplying them, you're going to add your exponents. So that becomes 5 plus negative 5. So that gives us 2 to the 0th power. Now, most teachers are probably not going to want you to leave it like that, so that's why we're showing you this rule. So 2 to the 0th power equals 1. Again, just because anything to the 0th power is going to equal 1. And so lastly, we have an example that has division, and so we have z to the 7th power divided by z to the 7th power. So a couple ways you could tell this equals 1. One way you could just say, anything divided by itself is going to equal 1. But also, if we were to take our exponents and subtract them like you do when you have the same base being divided, you would still get 0. So this would also come out to be z to the 0th power, but then, of course, you would simplify it, and you would just write 1. All right, so this next property is a pretty big, important property to know, and this deals with negative exponents. So an important note to make is that negative exponents do not necessarily mean you get a negative value. Okay, so negative exponents essentially equate to getting smaller values. Let's see what it looks like with number 1. So x to the negative 3rd power. Okay, well, I imagine almost no teacher would ever want you to keep it as x to the negative 3rd, because our goal when we simplify exponential expressions, one of the big goals is to make sure there are no negative exponents. So what you would do with that, if you have x to the negative 3rd power, what you would want to do is you want to turn this into a fraction, and you're going to move that down to the bottom, down to the denominator, so x, and then you're going to get rid of your negative sign, so you just keep it as x to the 3rd power. And now we're going to put a 1 right here. So x to the negative 3rd power becomes 1 over x to the 3rd power. And that's how you get rid of negative exponents. So now let's do a couple examples. So the next one, we have x to the 3rd power, y to the 2nd power, times x to the 4th power, y to the negative 7th power. Well, now we're bringing in the product rule again. So x to the 3rd power times x to the 4th power is going to be x to the 7th power. Now y to the 2nd power times y to the negative 7th power, that's going to be 2 plus negative 7, which is going to give us negative 5. So we get y to the negative 5th power. Now, again, we don't like negative exponents, so we have to get rid of that negative exponent. So what that's going to be is, well, the x has a positive exponent, so I'm going to keep that in my numerator. So I get x to the 7th power over y to the 5th power. So again, we get rid of that negative symbol, or that negative sign, when we take it to the bottom of the fraction. All right, so let's do one more. We have 2x to the 8th power, y to the negative 1st power, and now that whole thing is being raised to the 2nd power. So first of all, let's think back to what we talked about earlier. Well, this exponent of 2 is going to apply to all of the values inside of our parentheses. So 2 raised to the 2nd power, we get 2 to the 2nd power. Then x to the 8th power raised to the 2nd power is going to be x to the 16th, because remember, we're multiplying our exponents. Then we have y to the negative 1st raised to the 2nd power. That's going to give us y to the negative 2nd. And so again, we do not want that negative exponent, so we have to rewrite it. And actually, let's do this. While we rewrite it, let's go ahead and evaluate 2 to the 2nd power. We know that's going to be 4. So 4x to the 16th power over y to the 2nd power. So that would be the simplified answer. Okay, you just essentially really do not want a negative exponent in your expression. All right, and so the last thing I want to really quickly mention is when you have an exponent of 1. So when you have an exponent of 1, essentially that's just telling you you have 1 of your base. So 3 to the 1st power is just 3. So kind of what I'm getting at is if you have an exponent of 1, you don't have to write that. It's kind of redundant. It's kind of like when you have a variable by itself, like x. It's assumed that there's a coefficient of 1 right there. It's the same for any value that you're not given that has an exponent. So like this x I just wrote would actually technically have an exponent of 1 right there, as would the 1 right here. We just don't usually write that because it's kind of understood that they have an exponent of 1 anywhere. So, for example, the next one, 2 to the 8th power times 2 to the negative 7th power. Well, let's go ahead and add those exponents real quick. So 2 to the 1st power. And so you can leave it like that. No one's going to be upset about you leaving like that. But, again, it's kind of redundant. You can just write 2. 2 to the 1st power and 2 are the same thing because we're just saying we have 1 of our base. And so it's just 2. And so, lastly, we have x to the 6th power divided by x to the 5th power. Well, we'll take our exponents and subtract them. And so we get x to the 1st power, otherwise just known as x.